Hello everyone. In this video, we are going to derive one-dimensional Schrodinger equation. So first of all, we will start with the plane wave. So plane wave, let's say plane wave is given by psi xt is equals to a exponential iota kx minus omega t, where k is wave number and omega is angular frequency. Now, as put forward by de Broglie, he said that p is equals to h upon lambda. And what if we multiply and divide by it by 2 pi? So we here multiply it by 2 pi and divide it by 2 pi. Now h upon 2 pi is h cross and 2 pi upon lambda is k. So our p equals to h cross k. So from here k equals to p upon h cross. Let's say this is our equation 2. Now from Einstein's equation we know he suggested that E is equals to h into frequency mu. Now, what if we again multiply and divide it by 2 pi? So we will get like h cross by omega. So from here we can calculate omega. Omega equals to E upon h cross. Let's say this is equation 3. Now we will replace values from equation 2 and equation 3 in equation 1. So what we will get? Equation like this: psi xt equals to a exponential iota h cross px minus et. Let's say this is equation 4. Now what if we differentiate it with respect to x on both sides? So what we will get? We will get minus iota p upon h cross, and this term remains same. Now focus on this term. This is again psi xt. So I colored it over here like sky blue, and we take this h cross and iota on other sides. So we will have like minus iota h cross d psi upon dx equals to p psi xt. Now comparing on both sides, so we can see that we can say p operating on psi is same as minus iota h cross up into d upon dx operating on psi. So momentum operator is given by p minus iota h cross upon d by dx. So this is your operator, first operator in quantum mechanics. Now, uh, let's say we again differentiate uh, uh, this term, equation 6. So we will get iota h cross d2 psi upon dx square. Now again, this iota h cross will come ahead, and this p will become like p square. So again, this a iota h cross px minus et is psi. We replaced here psi. Okay. Now all the other terms like iota and h cross we take to other side and divide both side by 2m. Okay. Now what we see here, that this p square upon 2m is kinetic energy, or energy of free particle. So we can write it like minus h cut square upon 2m d2 psi dx square equals to E psi xt. This is your equation 7. Now considering the equation 4, if this was our equation 4 when we have this momentum and energy terms in plane wave. So again, partially differentiating both sides with respect to t. Now, when we differentiate with respect to t, we will get like this term here. Now, again, this sky blue term is psi xt. We replace psi xt. So what we see here, this energy is operating on psi, same as iota h cross psi, partial derivative of psi with respect to t operating on psi xt. Okay. So this is your energy operator, you can say. Now from equation 7 we can it can be modified that for in place of energy, we can write like this. So this is one-dimensional Schrodinger equation for free particle. Okay. Now we want a rigorous solution for one-dimensional solution. So we have three important results. First result is iota h cross partial derivative of psi with respect to t is equals to e psi xt, and this term we have derived when we partially derivative psi with respect to x two times. Okay, so we get this solution here, and let's say we have a potential energy v psi xt and v psi xt. Okay, well, let's say v is operating on psi, we will get v equals to psi. Now we know that total energy is given by p square upon 2m plus v. Okay, so this is E. Let's say this is total energy. This is equals to sum of these two, p square upon 2m plus v. So it means iota h cross, this term, first term, must be equals to sum of these two terms, minus h cut square 2m d2 psi dx square plus v psi. So this result we get. Now this is the Schrodinger one-dimensional equation. Thank you so much.